Hello, my name is Krzysztof Rzadca. I work as a visiting researcher at Google and as an associate professor at University of Warsaw, Poland. I'm going to present Autopilot, a tool we developed to automatically scale the workloads in Google internal cloud. Our internal cloud, a job, can serve YouTube or Gmail to millions of end users, or it can be a batch computation, recalculating database indices. No matter what is the job type, to launch it, we pack it in a container. The key feature of the shipping container is the metal box that surrounds the payload. This metal box protects the payload from the outside, among others from the payloads of other containers. Similarly, a Linux container isolates workload by setting limits on the maximum amount of resources processes running in the container can request. The actual usage is usually much lower. What is left is slack, memory or CPU that is allocated but idle. As with shipping containers, you have to pack your machines by the size of the external box, the limit, and not the actual payload. What you see here is a machine that executes 3 containers. The limits are just about right, slightly higher than the actual usage of the containers. There are 2 kinds of problems with imprecise limits. First, limits can be set too conservatively. Jobs are safe, but resources are wasted. The machine cannot accommodate another container, yet the actual utilization of the machine resources is low. On the other hand, if we set the limits too aggressively, as on the right, container could request more resources than available. If this is memory, such a container will be killed with an out-of-memory error. Autopilot is a tool to automatically set the limits and the number of containers a job is executing. Autopilot is a controller working in a feedback loop. Autopilot recommenders compute resources limits for each job. These limits are forwarded to Borg, our scheduler, which then contacts schedulers on individual machines, the Borglets. Borglets set C-group limits. We continuously monitor usage of resources of each container. This resource usage log is then read by recommenders. The moving window recommender uses simple time series methods to calculate limits based on the actual signal. We calculate the statistics of the usage falling in a moving window, such as the 98th percentile of the signal. We then smooth the response by exponentially decaying the input. Finally, we add a safety margin. This simple mechanism is sufficient to show significant savings. However, different categories of jobs require different tuning of the safety margin and the decay rate. A job with unstable usage requires more smoothing than a stable job. Our machine learning recommenders use reinforcement learning to automatically optimize these parameters. See our paper for details. To measure the efficiency, we did an observational study of 20,000 serving jobs. We computed slack for each container, the fraction of allocated but unused resources. Autopiloted jobs have significantly smaller slack. The average slack is just 23%, compared with 46% for manually managed jobs. To summarize, Autopilot shows the gain from automating cloud resource management. Humans are bad at setting the limits precisely. With Autopilot, our fleet runs more efficiently. The relative slack is reduced by a factor of 2. Additionally, as we show in the paper, the risk that the jobs have because of the out-of-memory errors is reduced by a factor of 10. So this efficiency gain is effectively for free. Thank you for your attention.